you find this video helpful, please like, subscribe and press the bell icon for notifications. So guys, from this video onwards, we will be focusing on first year engineering linear algebra topics. So our first topic in this series is system of linear equations. So a system of linear equation is a collection of two or more linear equations with two or more variables like x plus 2y is equals to 0, x minus y minus z is equals to 1, 2x minus y plus z is equals to 4, and all of these equations are linear equations in standard form. Now if we solve these equations, then we will get values of variables x, y and z that will satisfy all equations simultaneously, means at the same time, and that will be the point of intersection or common point for all the linear equations. So now system of linear equations might have one infinite or no point of intersection. So let's discuss this part in detail under types of system of equations. So there are two types of system of equations, and these are consistent and inconsistent. So let's talk about consistent first. So a system of equation with one or infinitely many solutions is consistent. So if a system of equation has only one solution, then it is consistent, or if it has infinite number of solutions, then also it is consistent. Now consistent system of equations can be independent or dependent, or we can say linearly independent, where they have different slopes and cannot be written as linear combination, or linearly dependent, where they have same slopes and can be written as linear combination. Let's take linearly independent first. So if x minus 2y is equals to 1 and 2x plus y is equals to minus 1 be two individually defined lines in the plane, then on xy plane, this line represents x minus 2y is equals to 1, and this one represents 2x plus y is equal to minus 1. Therefore, solution of the system of these two equations will give us a point of intersection x, y, and this point lies on both lines simultaneously. Now since these lines are intersecting at only one point, so it has only one solution and hence it's consistent. And these two lines are not depending on each other, both have different directions, different slopes, and therefore they are linearly independent. Now for linearly dependent, let's take x plus 2y is equals to minus 1 and 2x plus 4y is equals to minus 2, and on the xy plane this red line represents x plus 2y is equals to minus 1, and this blue one represents 2x plus 4y is equals to minus 2. And as we can see that these two lines are collinear. Now let's take 2 as a common factor here and cross out these 2's. We will left with x plus 2y is equals to minus 1, which is same as this equation. So these equations are really the same equation, just multiplied by 2. Now since they are collinear, So there are infinite points of intersection, therefore infinitely many solutions. So it is consistent, and both lines have same slope and infinitely many solutions, and they can be written as the linear combination too. So these are linearly dependent and define same line in the plane. So it's consistent because it has infinite solutions, and it's dependent because it's the same line, or one line is the scalar multiple of other. Now system of equations is inconsistent if there is no solution. So let's take x plus 2y plus 1 is equals to 0, and x plus 2y minus 2 is equals to 0, or we can write these as x plus 2y is equals to minus 1 and x plus 2y is equals to 2. So on xy plane, this red line represents x plus 2y is equals to minus 1, and this blue line is x plus 2y is equals to 2. So as we can see, these two lines are parallel lines, means they will never meet. So there will be no point of intersections, means no solution. So since there is no solution, it is inconsistent. As we know that standard form of a linear equation is ax plus by plus c is equals to 0. So let's take one linear equation, and that is 2x plus y plus 1 is equals to 0, and now write it down as a parametric form of linear equation. So for that, this standard form equation can be written as y is equals to minus 2x minus 1. Now x and y is equal to, let's take one parameter t, then y will be, if we substitute t for x, then y will be minus 2t minus 1, or we can write it vertically to xy is equals to t minus 2t minus 1, where t is the parameter that parameterizes the points on the line, and all the points, like in our case, on the line has the form of t and minus 2t minus 1. That is, if x is t, then y will be minus 2 times t minus 1. So now let's plot few points on xy plane. So for t minus 2t minus 1, if t is equals to 0, then it is 0 minus 1, and 1 minus 3 for t is equals to 1, and minus 1 1 for t is equals to minus 1. So for every value of x, y is minus 2x minus 1, or if x is equals to t, then y will be minus 2t minus 1. Now let's write the parametric form of x minus 3y is equals to 4. So this can be written as y is equals to 1 by 3x minus 4 by 3. Now take parameter t, then x and y will be equal to parameter t. Now substitute t here, then we will get 1 by 3t minus 4 by 3, and this is the parametric form of above equation. Next topic in this series is solving system of linear equations. Thanks for watching.